We spend billions of dollars and countless hours treating body fat like a relentless enemy, an invader we have to constantly battle, burn, and blast away. But if we look at what is actually happening on a cellular level, that perspective is backward. The human body views fat as a brilliant, life-saving tool. It is an ancient biological blueprint designed with one primary goal: to keep early humans alive through long winters and extended famines. We carry that exact same hardware today, even when we are sitting in an office with endless access to food. When you gain weight, your body is executing a highly efficient preservation mechanism, operating exactly as intended to save you from a hypothetical period of starvation. To figure out why this ancient survival mechanism is triggering excess weight gain in the modern world, we have to look past the surface and zoom in microscopically to see how your body actually manages the energy you consume. Seeing exactly how this microscopic energy pipeline functions allows us to stop treating our metabolism as an obstacle and start viewing it as a system with a set of predictable rules. It all starts with digestion. Whenever you eat a meal, particularly one rich in carbohydrates and sugars, your digestive system immediately begins breaking that food down. The end result of that breakdown is a simple sugar called glucose. You can think of glucose as pure liquid energy, the foundational unit your body runs on. Complex food particles break into glowing glucose nodes in your bloodstream, delivering immediate fuel to your brain, muscles, and organs. Your pancreas then releases insulin. This master key opens specific channels on muscle and liver cell walls, allowing glucose inside to be burned. But a modern meal contains far more fuel than you can burn in a single sitting. So what happens to the leftover glucose when your immediate survival needs are already met? While immediate energy needs take priority, your biology refuses to waste a single drop of fuel. The remaining surplus triggers a highly guarded secondary storage protocol. That leftover glucose is redirected straight to your liver and muscles, which act as the body's short-term energy bank. Once inside, the glucose is packaged into a stored form called glycogen. This glycogen sits in reserve, acting like an internal battery, ready for a sudden sprint, a quick workout, or a stressful situation. This energy reservoir fills rapidly. The storage space inside the liver and muscles is quite small. The energy units hit a hard ceiling, triggering a 100% full alert. Evolving in environments where food was scarce, your system will not discard extra fuel. Hitting this strict glycogen capacity limit forces your biology to find a new, permanent home for the overflow. The burden of dealing with that excess glucose overflow falls directly on your liver. The short-term banks are closed, and the fuel keeps arriving. To handle this dangerous buildup, the liver activates an automated biological protocol called lipogenesis, which literally translates to fat creation. On the liver's factory floor, lipogenesis activates. Raw glucose nodes are mechanically consolidated into dense energy bundles called triglycerides. Sent back into the bloodstream, they travel to their final destination, empty structures known as adipocytes, or fat cells, your body's infinite storage facility. Most adults do not grow new fat cells. Instead, existing fat cells absorb those arriving triglycerides, swelling outward and inflating physically like tiny water balloons. These expanding cells represent the successful execution of an energy preservation system for infinite long-term storage. If we zoom back out from the cellular level to look at the human body as a whole, the picture becomes a lot clearer. Visible body fat is merely the physical manifestation of saved surplus energy. It is biological currency, safely locked away and waiting for a moment when you might need it. And because this is simply a mechanical storage system, the entire capacity cascade can operate in reverse. The trigger for that reversal is a caloric deficit. When you consume less fuel than your body requires for its daily operations, the immediate glucose supply dries up. This abstract visual demonstrates how a caloric deficit safely mimics a historical famine state. To make up for the missing energy, your body pulls the packed triglycerides back out into the system, which causes the cells to physically shrink and deflate. Understanding the capacity cascade turns the metabolic process into something predictable. It transforms a perceived struggle into a series of biological inputs and outputs that you can finally manage.